They've given the problem and they've asked use SRTF and find out the average waiting time. Okay, that is what given in the problem. Now let's find out. Okay, let's first draw the Gantt chart. Okay, Gantt chart starts with time unit 0. Fine. Now at time unit 0, the only process which has arrived to the RAM is nothing but P1. So we will schedule P1. Fine. Now it will execute at least till 2. Okay, which means its remaining execution time is 10. Now we have only P1 and P2 inside the RAM, out of which P2 has the highest priority because its execution time is lesser, right? So P2 will continue at least till 1 time unit, right? Which means it becomes 3 and P2 will continue at least till 3. Fine. Now at time unit 3, we have P1, P2 and P3 inside the RAM, right? Because P4 is arriving only at time unit 8. So out of these 3, the process with the highest priority is nothing but P2. So P2 will be again continue at least till 8, but it needs only 3 time units. So it will complete its execution after 6. Okay, so it will become 0. Now at time unit 6, we have only P1 and P3 inside the RAM, out of which P3 has the highest priority. So P3 will continue at least till 8. So if it continues till 8, then it becomes 4. Okay. Now we have P1, P3 and P4 inside the RAM, out of which the process with the highest priority is nothing but P3. See, as right now all the processes has arrived to the RAM. Okay. Now our SRTF scheduling algorithm will behave exactly like SJF scheduling algorithm from now on. Okay. Till now it was behaving like SRTF, but from now on it will start behaving like an SJF scheduling algorithm. Okay. Now see this. Now we have P1, P3 and P4 in the RAM, out of which the process with the highest priority is P3. So P3 will still continue till 12 and then it will complete the execution. Fine. Now we have P1 and P4 inside the RAM, out of which P4 has the highest priority and so it will complete its execution till 17. Okay, so it will become 0. Now again P1 will be scheduled and it will complete its execution after 27 time units. Okay, fine. This is the Gantt chart. Now let's compute one by one. Okay, let's compute the completion time. This is P1, this is P2, this is P3 and this is P4. Okay. Completion time of P1 is 27. Okay. Completion time of P2 is nothing but 6. Okay. Completion time of P3 is nothing but 12. Completion time of P4 is nothing but 17. Okay, now let's compute the turnaround time. Turnaround time equal to completion time minus arrival time, right? Completion time minus arrival time. Completion time is 27, arrival time is 0. So it will become 27. 6 minus 2, which is nothing but 4. 12 minus 3. See, 6 minus 2 is 4. 12 minus 3 is 9. Okay. 17 minus 8 is nothing but again 9. Okay. 17, which means it has completed its execution at 17 and it has arrived to the RAM at 8, which means it has a turnaround time of 17 minus 8, which is 9. Fine. Now let's compute the waiting time. Waiting time equal to turnaround time minus burst time. Okay, 27 minus 12, which is nothing but 15. 4 minus 4, which is 0. 9 minus 6, which is 3. 9 minus 5, which is 4. Okay. Now we were asked average waiting time, right? So average waiting time is nothing but 15 plus 0 plus 3 plus 4 divided by 4. Okay. 15 plus 3 is 18. 18 plus 4 is 22. So 22 divided by 4, which is nothing but 5.5. Okay. 5 fours are 20. We have 2. So it becomes 20.20 and becomes 5 fours are 20. So 5.5 is the answer. Okay. So the average waiting time is 5.5 for this problem.